Okay, we're recording. Good morning. This is Durwood King with Sampson Community College. This class is MNT 110. And this is November 10th, 2020. And today we're going to be covering shafts, couplings, and alignment in our book. So it's a very informative chapter, and we're going to be doing a lab on alignment. So Brandon, if you're out there, we hope you're doing well. We hope you and your dad are doing well. Give me a shout. Let me know how you're doing. I haven't heard nothing back from you. Let us know how you're doing. I'm going to shoot him a text real quick. Okay, so here we go. Let's get our books. Let's see. Come on over this way. Brandon, do you? Huh? I'm just trying to find a spot where I can set up with the camera too. If you want to make it right there, it'll be fine. I'm sort of trying to get an angle here. What's he saying on the text there? So is he going to join Zoom? Yeah. If you will, text him so I don't have to stop and ask him, is he going to join? Y'all can be fine. Challenging, and a little challenging, but not too bad. No, just doable. I love this camera, man. What do you think? Man, this thing is woo, nice. Okay, so what did you reply back? Yeah, he knows to get in if he can, if he can get in. Okay, so anyway, y'all look at the book there. Shafts, couplings, and alignment. Let's just kind of get the high spots to go through. There's not going to be time for me to create a worksheet to put it in there, but we got to cover it. Okay. And you may see some stuff in the exam on it, like maybe some pictures, and you may want to, as far as identifying some things, what kind of coupling is this, so on. There may be some things in there, so we pay good attention to it. So some high spots in here.
He said he was. He said he was going to join.
Okay, good. All right, so one of the ideas that we've already covered in gearboxes is the idea of checking run out with a dial indicator. And they're showing here on this picture, seeing a shaft from the end of it, and then seeing the radial run out up and down like this if it has wobble to it. So that's the case in no matter what you're checking. If you go to something like this over here, you've got a rigid coupling here. If you separate these two, then you can check the run out up and down on the driven machine and on the motor the same way you did with the gearbox. You've got shafts, you can still have wobble this way, or the loose play in the bearings. Okay, so that stuff can be checked when you decouple them. You can put a dial indicator here and then jerk up and down, or either rotate it, and you can check just by rotating it to see if the shaft warp. You can check by jerking it up and down like that you have a lot of loose play in the bearings. You know what I mean? So that's your radial run on the driven. The same thing on the motor end of it, but you got to decouple, take the screws out to do that. It's the same thing as what we did before. You can check the axial run out. You got to decouple them, separate them, and put the dial indicator facing the shaft, and then pull in and out like that, and you'll check for worn bearings and all. So that's one of the preliminary checks. Yeah, he's in. Hey, how you doing? Okay, so anyway, that they're just showing you that's one of the preliminary checks whenever it says run out. Run out is measured by placing a dial indicator on the outside diameter and slowly rotate the shaft. It can impact the functionality and the longevity of bearings and seals. So bearings and seals can be affected by run out issues. If you've got keys that you're dealing with, you can look for a cracked key seat. The bed that the key goes in could possibly be cracked. That's another thing. They get into different ways to support the shafts, pillar block bearings. Showing the grease fit here. They're showing here how our bearing can fit against the shoulder of the shaft. Here you've got a 2-bolt flange bearing. You've got a U joint or like a universal. Universal joints is one like this, to where you've got shafts, you got to drive something, but they're at an angle. So here you can drive something at an angle. I think like drive shafts on vehicles, you've got the universal joint like that, or knuckle like that. That allows for some misalignment there. And they're just showing you an example right there. If you read through all this stuff, here's another kind of coupling here that has an elastomeric element in there. It's a flexible type of element that's going to allow, it's going to sort of dampen it, and it'll allow for a little bit of misalignment. It says here that for flexible couplings and misalignment, even though a certain amount of misalignment is tolerated, flexible couplings still transfer. Flexible couplings still transfer vibration due to misalignment. So even if you got a flexible coupling, that doesn't mean that you can tolerate misalignment, because a lot of misalignment is you're still going to transmit some vibration through that elastomeric coupling there. Parallel misalignment causes the driven machine shaft to bind and butt on each shaft revolution. Slight angular misalignment may not cause the coupling to fail, but it will reduce the lifespan of the machine's bearing. So You still want to shoot for perfect alignment as good as you can get it, even with a you know, elastomeric type. Now here, you got something called a sleeve coupling. It's got a neoprene sleeve between two synthetic rubber hubs. So here, we've got one right here, and it comes apart like that. That's something similar to that. So you got that. Okay. So that would be your element that you wear right there. If it grips, that's pretty neat right there. It's interesting how many designs that there are that people have come up with. So again, you know, you've got set screws here that go onto your shaft, and that's a pretty neat, you know, invention there for design. Then you got something called gear couplings, and then you've got grid couplings. Grid couplings is something that I do have. The grid, there goes the gear coupling right there. I don't have one of those to show you, but I do have grid coupling. So grid coupling has a springy looking thing in there. And let's go up. Don't get dizzy there, Brandon, with this thing floating around. So here you've got something called a grid coupling, and it comes apart. It has a shell, and there will be screws through there on each end, and there's actually a grease fitting here. So you would shoot grease into it. You have to put a grease fit in there and pump it full of grease. And look at it. As that comes apart, there goes your grid. And so it allows, you notice here, it allows some floating like that. And so it's but if you have, you know, if this cracks and goes bad, of course, you're going to be taking the shell off like that, and you would have to replace the grid itself. It also has seals in there, seals, and the seals are going to try to keep the grease in there because it does have grease bit. Right there. There goes your grease bit in there. So it does need to be go back in like that. You want to take a look, pass that around. You got those. Okay. Got an oyster there. You feel better, Brandon?
Man, I don't know what in the world is. I got like a little muscle aches down my back. I've been coughing a little bit.
How's your daddy doing?
He's doing better, but then my mom got it like a week after he tested positive.
Yeah. Well, look, have you been? I haven't checked the logs to see if you've been watching these videos. Have you been watching the videos?
If not, don't answer the question. Just go watch them real quick.
If you haven't watched them, listen, you need to get in there and watch them to get credit for being in the class, or else you would probably end up being dropped, okay?
Okay.
You've got to watch them. If you don't watch them, then I can't count you present, and you would technically have to be dropped for overcut. And make sure that you get, let me put the camera on me. We know how urgent this is. Okay, here we go. You see me?
Yes, sir.
Listen real good. Today and Thursday, this week is the last week you'll be with me. You got to get your worksheets done by the end of this week, because I can't grade nothing after Thursday, no later than Friday. Friday is the cutoff date. I can't grade anything after Friday because I'm getting ready for surgery next week. So, okay. You hear that good?
Yes, sir.
So you got to get your stuff done. Whatever's not turned in by Friday, I'm going to go in and move and put zeros in there, including the absentees on classes and stuff like that, the worksheets. The exam is going to be, now, this Thursday is the 12th. Okay, this Thursday is the 12th. That's the last regular class day. Now, next week,
Okay.
17th and 19th, when you be in here, you're gonna go on Moodle, pull up your worksheets one at a time, go to the right side of the screen, and you'll hit review. You go in and look at your results, what you got right, what you got wrong. You can print. You can print these worksheets to a PDF file and save them on your device. Do you hear that?
Uh-huh.
You can print those to a PDF file, save them on your phone, save them on your computer. Then you can also print them on paper. That's going to be your study guide. The exam is going to consist of all the chapters that we covered, plus a few things off of this chapter on couplings that we're doing right now. There's not, I don't have time to put a worksheet online for this chapter 11 on coupling, but you can look, you need to study it because there could be a few questions on there from this chapter, okay? Like maybe some pictures, and then what type of coupling is this? I would put some simple stuff in there like that, some different ones, multiple choice. You know, is this a grid coupling? Is it a spider coupling? You know, what kind of coupling is it? So the exam will consist of about an even number of questions off of each chapter we covered the book. This exam will count as the entire test portion of the grade, because we can't done any other test.
Yeah.
Normally we would be doing a 2 or 3 tests by now, but there hasn't been time. My choice this time was to focus on shop and do one test at the end. Now the risk on that is that if you do bad on that test, it's going to count that portion of your grade. It's going to sway it significantly, okay? But if we could focus on the book more and done the testing, you wouldn't have hardly got nothing done in the shop. That was the trade-off, because this is a really short class. So you hear what I'm saying there?
Yeah.
Okay, good. So everybody understands that Thursday is our last day in here regular. You got next week to print. I'll get everything graded the weekend, okay? As a matter of fact, tomorrow I'm going to catch up what you've done so far. Now by Friday, when I go in there and grade stuff on Friday, then whatever's not turned in, I'm going to have to put zeros in there. And I can't grade it after that because I've got surgery coming up early next week. I can't grade now; they'll be cutting on me. Okay.
Okay.
So they'll be, you know, doing. So I can't. You got to get this stuff turned in. Even if there's a gap next week, you can't turn stuff in next week because I can't grade. So I can't finalize stuff. Listen good here, Brandon. On the 24th, which would be the next week. Next week you got a gap in there to study for the exam. The following week, on the 24th, on Tuesday the 24th, everybody listen. That is the exam. You have to come on campus to do the exam, is what I've been told. Now, in your case, I've got to find out from Barney what in the world to do, because if you're still in quarantine, what you need to do, Brandon, you're gonna have to let me know, are you still in quarantine at that point?
By the 24th, I'm pretty sure I'll be out of quarantine.
So what you're gonna need to do is this. I'm gonna leave it. You're gonna have to tell me and remind me, because as of right now, they're telling me that because we're not using a Respondus lockdown browser for exams, you can't do them off campus. They say if you do them off campus, it won't count.
Yeah.
Somebody else is going to be recording somebody else is going to be proctoring the exams on campus. Here's what we're going to do. On the 24th, on the normal class time, you got to come in here to the shop. Listen real good. You come in our classroom over here in 146C at 9 o'clock. Listen real good. So on the 24th, you come to this classroom in the shop. Somebody's going to take you to a computer lab that may be on this hallway. I'm not sure where they're going to take you. You go to a computer lab and you do your exam using a school computer with a proctor person in there, making sure that your computer is good and all that. Okay, so does everybody understand that?
Yeah.
So that exam will be done at 9 o'clock. It'll consist of portions of your worksheets, okay, and some pictures in the book, and some questions, and it may be I may ask a couple questions about labs that we've done. Okay, it's going to be fair and square, no surprises. It'll be very straightforward, no tricks. So everybody good. So what day is our exam? November 24th. Which is, and how about next week? What do we do next week?
Steady.
You study and listen. Go every one of your worksheets. Go in there, even if you don't put them on paper. Go in there, and when you pull up your worksheet in Moodle, hit review, and then you can print to a PDF file. Give it a name, save it on your computer, save it on your smartphone, wherever you're going to save it to. Because that's the only way, that's the only thing you're going to have to keep from all of your work. After the course is done, you don't get in there anymore. You're locked out then. So make sure that you do save your work. Everybody good? Okay. All right. Great. Okay. And let me know if you have any issues at all. Now, the next type of coupling here is called a jaw coupling. The jaw coupling is a three-piece unit that transmits power between two hubs. They're meshed together with the assistance of an intermediate element called a spider. The spider, made of metal or various polymers, allows the misalignment while reducing wear to the metallic hub. The material used for the spider can impact the ability to discount vibration, temperature, and chemicals. The type of spider used depends on your operation environment and then your specs. So here we have a spider coupling. Right there, it's called, the brand of this one is called a Lovejoy. That's probably the most popular coupling that I've ever seen from where I work at. There goes the spider. So they call the spider there. And these, you know, they just wear over time, and you start to get a whole lot of slop in there, a lot of backlash when they wear it. You can picture that. That's easily seen there. They work very well. They do allow some float going on there, a little bit of misalignment. But you still want to be able to do alignment with them. You still want to try to align these. For instance, like with a straight edge here. We're going to go with a straight edge method here, and you'll put a straight edge across them, and you'll be looking for daylight under one or the other when they're bolted onto the machine. So we still go with in the beginning with a straight edge method, and then you can go dial indicator, and then you can go laser. So those are the three ways we're going to try to do alignment. So moving right along. There's some pre-alignment checks that you go through. Lockout, tagout is one of them. Is the first one, the main one. Checking for tight pipe strain is one of them. Anything connected to the machine may place excessive strain. Clamps, jacks, and other pulling tools should not be used to make connection. If excessive force is required to make connection, the piping needs to be reworked. To see if stresses are affecting alignment, set up for alignment and then loosen your piping, like maybe your unions. If the dial indicator changes more than a few thousandths, there's too much strain on the machinery. Does that make sense? So you can put a dial indicator on a shaft and then loosen the piping for the pump. And if you see a movement, then you got issues with your piping. Okay, so that's a good idea there for pre-alignment checks. And then your base plate, check the base plate for certain conditions, voids, make sure it's level, free of cracks, and sealed from degradation. Properly anchored with the appropriate hold downs, that you clean it of any debris. And then checking the shaft run out, as I just said. The shaft run out is the same rules as it was with gearbox. So your excessive shaft run out greater than 3,000 is just do all that. Now, before we go further with that, there's some more couplings that they did not show in this book. Let's show those real quick, and then we'll get into doing an alignment. So you've got some rigid couplings that absolutely have no forgiveness whatsoever. See that? That's a plant coupling right there. It's got a keyway, and that thing's got to be dead on. Them shafts have to be dead on. Okay. You saw the universal joint. There goes another rigid coupling there, with no play whatsoever. So that's right rock solid there. Here goes an elastomeric type there, a different one. Pretty interesting, got a rubber feel to it there. Here's a different one here, just like a spider coupling. Like that, different brand. Clamp something like a square shaft. I've never seen one of those used on anything, but it's another variety there. And then you got something called chain coupling. This is very interesting here. So the chain coupling, you know, your shafts would they would attach with set screws, and then you've actually got chains in there. You got some room for some float in here for the chain coupling. And let's look at the where's our right here. Now, so there goes your master link. There goes the master link right there, and you pull. Oh, let's get the lights. That light. So here you've got the master link for a chain coupling, and you pull that master link out like that, and it comes apart. So there you go, right there, and there goes your two pieces of your chain coupling. Let's get this up. Pretty interesting, huh? So it's like two gears, and you have a double gang chain there. That's actually the element that does the transmit the power. There goes your set screws there. We'll line those up. You ever seen anything like that? Okay, you have. This thing's bad at the bone. In other words, like Ruben would say, that's bad at the bone there. You know, that thing ain't messing around. What kind of machine do you have this on?
My capper.
What?
Capper is
Capper. And so this is driving between what is it coupling together?
between the main gearbox and the drive motor.
The motor. Okay. So it's pretty serious drive there. Real serious drive. Have you ever had one of these that the chains go bad or anything?
Yeah, you don't have to keep them lubricated.
You got to keep them lubricated.
In our environment.
Right, because you got wet chemicals and they're spraying them chains down with disinfectant every night on third. So they're getting some serious chemical attacks on everything in this plant.
They last a long time.
Right. But isn't that interesting how somebody invented that? I think that's interesting. It's fascinating to see all the inventions that people come up with in just in one subject like couplings, isn't it? To me, it's very fascinating.
We have to have those on the captain. So any slack at all will throw your timing off for the captain.
Yeah.
So you got to kind of move it off.
Let's let you say that again there. Say that. Go ahead. He can tell you from experience because tell him again.
On our cappers, we use this type of coupling because the regular coupling might be love to. If you get any wear in it at all, it tends to float. It throws the timing off. So we have jars going through our capper. It has to be hot and super thing. If it's off just a little bit, that's what I mean.
Got to be nice and tight. But yeah, it has to have some axial flow a little bit, but not radial wise. Okay, then this is even just as much interesting here. What do you think that is at a glance? It's a nylon chain. It's a nylon chain coupling. So with this one, we'll drive a pin out and let's see which one it doesn't matter which one we drive out. Looks like that one right there has been driven out before. So let me get something to drive that out, and we'll take that apart. Give me just a second. I need to get the small pin from
So if you don't have a longer chain, there's something else with just a short chain. But usually it's a regular chain. trigger the double 59. It has to be a certain.
I don't know, I'm saying like, put this on there, you want to share. All that does is just share.
Yeah. That's not a regular problem. They could be
I might grab that hammer out there. Mm-hmm. Now, if y'all will drive one of these pins out, I don't think it matters which one. I don't see any difference in them, honestly, but that one right there's probably the one that's been driven out for it. You can kind of put it up here where we can see what you're doing. And I'm gonna hold it like that. So we're using the flat pin punch. Now we're gonna pull it out with some needle nose. I'm gonna advertise for Tractor Supply here. Tractor Supply, you can get this Gerber suspension. Check that out. Look at there. Tractor Supply. I think it was about 40-something bucks. I didn't even have to go to the toolbox. And I'm hoping, I'm hoping this one come on out. Look at here. Look at there. It's got some pretty good grip to it. If it don't make a wire out of it. Now, so we pulled that pin out. It's just going to come apart like a regular chain there. So there you go. You got the same deal there as with the metal one, but it's a nylon chain couple. So ain't that something? Interesting. Nylon chain. So food processing, that may be thing for you. Chemicals. Pretty interesting, huh? Set screws here. The whole this. There's you got a set screw coming in right behind the keyway. So that's to keep the key from slipping out. And then you got another one to bite down at a 90-degree angle. They come in from two angles with the set screw. So that's pretty good design there. We'll line those up like that. Close it up like that, and we're going to let you drive that back in. If you wanted to use you want to use the pin punch maybe to align them better. Look at there. So there you go, chain coupling. It's got a little bit of float to it. Anyway, so that's another variety there. By the way, that was a set of proto pin punches there. Real handy. These can be used for not only knocking out pins, but they can be used for lining up flanges like drift pins. If you don't have drift pins to line up flanges and you're doing pipe fitting, you can use these in the place of drift pins. So that's a handy thing to have. It's not real expensive, and you don't have to buy something separate called drift pin to take the pin. So that's a pretty common thing to have in your tool case, toolbox. So next thing is we'll go to a basic one of the first checks that you'll do when you're doing shaft alignment is something we haven't talked about. It's called soft foot. Check for soft foot. Soft foot is a condition where the feet of your machine do not make perfect and even contact with the base plate. Soft foot can result from one or more feet are short. You got a foot floating, okay? Maybe on the motor or on the previous machine. One or more feet were improperly formed during manufacturing. One or more feet are bent. Sometimes you can get a motor, a brand new motor out of the box, and then one of the feet may be bent if it's a thin base. The base plate has an imperfection that's not level. So basically you got to go around and check under the feet. Under the feet, you're going to check with a feeler gauge or shims to see if you find any gaps under the feet when you begin, before you begin the process. You got to fill in the gaps so they get rid of soft foot. So that when you go to tighten something down, you're not warping it. That's one of the preliminary things. And then here, they give you different angles for check and run out. You can get it from these different angles, depending on what you're going to be checking. Now, we're going to start out not doing this, but we're going to start out doing a basic straight edge and feeler gauge method, and then we go on the dial indicator. So for checking for soft foot is here they say torque down all of the feet to the base plate, loosen one foot and use a dial indicator or a feeler gauge to check how far the foot lifts off the base plate. If you're using a dial indicator, mount it on the base plate and then zero the indicator, measure how much the foot rises when it's loosened. If the measurement is greater than 2 thousandths of soft foot, you want to insert the right amount of shim. Now we got shim packs that give them in all their small increments. We've got a nice shim packs in these boxes here. Then you'll retighten that foot and move on to the next one. You repeat it until you have corrected all the soft foot. And then when you complete, make a drawing that indicates how it was corrected. You would make a note of your shim layout. That way, if you ever have to replace that motor, you got a note of how you started out the shim at the beginning. Okay. They get into checking bar sag on your dial indicator. We won't get into that today, but the weight and how depending on how long that your indicator, your dial indicator is, you may have some bar sag. And so, as an example, right here, that right there, whenever you set this up, you can picture if this is clamped onto a shaft here with a chain, that the bar, you could have a little bit of sag in there possibly. And the longer that bar is, if there's other attachments that are longer, it could influence the reading by the weight and the sag of this. Okay, so that's something that they get into. That's the laser shaft line right there. We'll end up with that Thursday. There goes an example of a jig there for using a dial indicator. There's another one. You use a chain clamp, but the clamp it so you can stabilize it to get a reading off of a coupling. Let's start out with something even more basic than this. We come over here to the machine. You look at here. The other ball was working on these yesterday was gone. Okay. If you notice here, what do you see up under the feet here? You see some shims under there. They've already gone through. They've already done an alignment. So this is a rigid coupling. This is the most challenging type to align. Now, as far as what you want to end up with, is something like this. Second here. You start out with some very, very simple tools that you always have. But even if you don't have a dial indicator where you're at, you're gonna have this stuff. This stuff is very cheap, very easy to have. here we've got a straight edge. That's actually a cutter for a lathe. Okay? That's actually a piece of carbide. It's extremely straight like that. That goes on a lathe cut. Okay? We're going to use that as a straight edge. And we want to loosen, like these are loose right here, right? They're loose. Even though they're not going to run that way. I got them loose right now so you can see that they're not bound together. Basically, what you want to end up with is you want to have it so that when you lay that up there like that, and for instance, if we were going to say that you couldn't have any more than say 5 pounds gap in there, if you would be able to come in like this, put that straight edge on there and shoot behind her, see, I don't see any gap in there. I don't see any. See that? And these you can check it. Go at 90 degrees. So yeah, if you want to hold that, we're going to shoot down this way. Maybe go say at 9 o'clock and shoot it up like that. And there's a little bit. See that little bit in there? You see that? Right there? So that's kind of what we're getting at. This is the basic finger gauge method of doing it. You want to find out how much it's there. This has already been done. We're going to let you. We're going to take all of the shims out in just a minute and start the press. Okay. So here you go, the feeder gauge step. If you want to find out what that gap is, let's just see is it maybe like 10 pounds. We could just try to get 2 in this thing, and then they go from there. So I've got that in there like that. And 15's not going to fit, so it's better than nothing. Just shoot it on down and stay to the center. That's 11. That's 9. Where's the 10? Let's just try 9. There's a 9 in there. And there's 10. Let's get it. That's 10 pounds right there, just rough. So we go here, and we're going to see if possible 10 is maybe 10. And it will. So it's actually tighter than 10. But it's probably going to be more like 5. Okay? Let's shoot down 5. If we feel some drag, we're going to say that they certainly did. They did a nice job on it. Shoot down to 5. There may be a little bit of drag in there. It's between 5 and 10. Probably going to be more like it's very, very close. It's really part of the line. 36, which is 5. It's actually 6 with some rub. Get one that ain't rusty. There's a hole right here. I got one that ain't got no rust. Actually, on my car here, there's one that ain't got no rust on. I'll stay there. See, I've used this because you see how straight that is? That's a piece of carbide covered by this. I feel the difference. It's actually it's about a 7. It's about 7 pounds. It's pretty comfortable. On the top, it's perfect. So, but I let that go. Absolutely, I let that go. That's fine. There's nothing wrong with that. So we're going to start out now by, if you shoot the camera right here, we're going to remove these shims. We're going to take those out, start from scratch. And if you redo this, we're going to get, and we're not even going to make notes of how much shim to clear. And on here, you have an adjustment jack bolt here on the side, so you can do the uniform movement with these jack bolts here. And then you also have some play here on the feeder motor, and then also on the base plate. But we're going to leave the driven machine alone. We're going to assume now that this is maybe a pump that you're driving, and it's already plumbed in, and we can't move it because it's already been piped in. You know what I mean? You don't move the driven machine, you match the motor to the driven, because this is always the one you're going to match up. Okay? Any questions so far? Okay, so you can go ahead and take all that out. Just get our tools out, get all that stuff out, and start down the line. And again, we start out with a basic feeder gauge. And we are locked out here. We got a lockout device. That's very important. It's not just a rule we have to keep up with, but it's something to keep all of your fingers that you're going to need all 10 of them. The good Lord's give you 10, and you need 10 from the cradle to the grave. You need them. So
I might can do without my pinkies.
no, well, hey, take that pinky sometime too, but. I broke that finger right there one time by not locking out the machine.
Oh.
You can see right there where it drove back together.
Yeah.
Broke it in 5 places. All because I didn't lock the machine out. Somebody had bypassed something on the machine I didn't know about. They did a really severe bypassing something, and I didn't know it. And that wheel would come down, the spot would have come down on my hand, and it broke my finger.
Mm.
And I had to relearn. I played guitar. I had to learn how to relearn. Well, I'll show you how to. That's a C chord right there. That's a C. When I learned how to do it without the middle finger, I did. I put there's a C without the middle finger. There's a D without the middle finger. There goes a G without the middle finger. I started out when I broke it. I said, well, at least I can play bass guitar. You know, I said,
yeah.
I'm not going to give up. So I went home and I pulled my bass out, and I said, wait a minute, I still got 3 fingers. And a lot of chords just three fingers. So I come up and
3-note chords.
I can still do it. D, C, G. E minor right there, boom, right there. I can still jam with 3 fingers. I can still switch it. Anyway, not a good thing. Come on back here. Let's see where we are. You got all the same things? Now let's check the soft foot. So get you about a 5,000 shim, and shoot under each one and see do we have any soft foot. You can use a feeder gauge. Use a feeder gauge here. Here, let me tell you what it is. Actually, the book said that if you had greater than 2 pounds, just check them. I used to take a 5. Seven. That's 5 right there. Keep going around and see if you have soft foot. Just check under these. So is it touching there? You got it on all of them? you start out, let me get the shim pack out. Here, keep the camera on that. Here you got an active shim, pre-cut shim set. Now in there, they got the shims in them, and graduated thicknesses there. Start out at 1,000, 2, 3, 4, 5, 10, 15, to get up to 20, 25, and so on. Now them gone. I've got other packs that's got more in there. So you can try fill the gaps in so that it's most soft as you can. Between using these and using some of those over there. Actually, if you simply go by the method they said, go ahead and bolt all of them down, tighten all of them down, and release them one at a time and do it their method. Now I've seen two different methods. I've seen a different method online. Once you back up and try the method that they had mentioned in there, pull that out, tighten all those down, and then loose them one at a time, and just go strictly by what they said in the book, and just see what kind of result you get like that. And what I'm going off of, I've never seen it said this way, but let's just see what kind of result we get like this. Tighten them down and then loose them one at a time. Here what they're saying is torque all of your seat down, loose them 1 foot, and use a dial indicator or a feeler gauge. We can use the feeler gauge for speed. And we can do dial indicator to measure how far the foot lifts off the gauge plate. We can actually do the dial indicator that fast too. Okay. Dial indicator, we get this. That's a fast thing to do there.
Somebody gave me one of them the other day. Somebody gave me one of them the other day.
Really? Oh, good. We can move on in if you want to. Work good for you. Set it on there and then just roll it.
All right, read them stuff.
Now pull the shims out there. Yeah, pull the shims out. I've never seen this method being done now. Now tighten that one down too, and then we'll check the lift with this. I'm always open to anything I haven't tried. Whoever wrote the book, we're going to find out sort of what our results. Everything's tightened down nice and tight. Okay, so put the dial indicator on there now. Let me get one that's this. Here's the dial indicator we had over here in these trainers that have the wing nut on there. Yeah, so this has got the wing nut. I don't know what happened to that. But here, The dial indicator, the magnetic base, when you tighten this, then it sticks to the metal base. Come on up here. And we may or may not be able to make that happen. Checking in there that far in. We're going to try it too. That's going to be real. If you can shoot in, maybe bring it in where we'll zero it. We're going to go and come in this side and see what we're doing. Now, I've got it zero. Come around here and look. It's on zero. Now, if you'll loosen it, hold on a minute. This ain't tight here either. Tighten these here back. Here. All four of these. Yeah, so we're. That would definitely be have an effect on it. Right. So now we're going to come back in here and shoot. We're going to take off that foot there. It's at an angle. That's the best we can do. You can't move this straight on with it. So we're in there like that. We're going to zero again. See that right there? We're on zero. Now he's going to loosen the motor foot and just kind of do it maybe from this angle right here. Let's just see what kind of yeah, it's showing some of this right there. So if you look right there, we're looking at how many thousands, Pat? Maybe about 8. So 7 or 8. Okay. So we put the shim in there now, according to this method in the book. You shim it according to that amount. So you take care of your soft foot. You do them one at a time that way. So whatever will fit in there the tightest, you slide that in, and then you tighten that down, and we move around to the other one. That's a method that they recommend. I've never seen it done that way, but we're going to try that. Okay. I mean, I have enough respect for different authors and stuff that we'll do it. See how it turns out. So we're going to loosen the magnetic base here, and he tightened this one, and now he's moving around. See which one you're doing now. Well, you're gonna put shim in now. Does it have drag to it? Yes, sir. Okay, good. So he put that amount in there. He feels a little bit of drag on that. Nice and tight. Like torque it down.
It's tight. Torque it down there. Torque it down. You can get rid of it.
There you go. Now, so your next one, and this is going to be extremely difficult to do a dial reading.
Well, you got to put it on first. You need to put it on there first.
I got to put it on there first. So that one's going to be hard to actually do.
Put it on last.
We could do it last, yeah. Let's go around and do the other one. And I'm wondering if we could actually kind of a crude way of doing it. I actually took them off of the motor box right here because it's going to lift the whole motor when it lifts, right? So I guess we might be able to pick it off of this edge. But let's go around and do the other one. Here you got a wing right there. That's a lot better there set up. And Patrick, you might want to come around this way. So the foot's tight right now, right?
Yes, sir. You didn't lose your big beard. Is there? Don't see you up there.
Mm-hmm. Yep. And if we get on the screen there, pretty good. And then when you lose them, let's just see what happens then. Just move a little bit of them up. Seven pounds. All we're doing at this point, this is not really getting, this is not finalizing the alignment, it's just getting the soft foot so you can begin that. You will put the straight edge up there in two places and check the gap, and we may have to move the whole thing one way or another. And then, this is not what you would call a fast time. In some cases in plants, you may not have time to do all of this. But you may end up bolting everything down and then throwing straight edge up there and going out there. They're not giving you time to do all of this. Just in reality, you know. When the heat's on in the plant, you got to hurry up to get going. The more expensive the drive system is, the more critical it is to go get half that time to do it. So you don't end up ruining something too. You got a big old 154 circuit plant, it matters. You know, it matters if you get good alignment. There's a lot more at stake.
Good and back side. Right there. Me too.
It was already moved.
No, it's fine.
It didn't move that. So it said what, 2?
Yes.
You got a 2, you throw it in there. But we got some complete sets to do. Okay, we got more sense than that.
Yeah, put 3. 3. Loose. Put that in there. So that's 5. That was good.
So make you a knob.
Mm-hmm. Yeah.
Good job. 1, 4.
We can just do field gauge for particular guys. That's exactly right. Yeah. Because there's not room to do that. I just went through it because of the tab head there.
Need a washer there, Will.
What?
A washer.
Washer.
There.
Okay. For
This bolt over here is bottom out. This pad. Bolt's too long. Need a washer. The rest of it's got a lot wash. The rest of them moved. That one did. I need some kind of wash.
So, yeah, we got a lot of
It's good. Yeah, I got good. Yeah, I got good eats. I've already eaten. Huh? It's not breakfast. Lunch time. No, I'm supposed to be business.
we'll then tighten up before you put your thing there.
There he is.
And to hurry up. We got a bunch of Spanish girls at the town I work at. They say, I wish you would hurry it up. Hurry it up, not hurry it, hurry it up. And one of them, they grab my shirt. He pulled. You tell me you fixing my machine. I can't make my production. No working. You hurry up.
He said, you go help. He said, you go help.
Yeah.
It sounds like he's saying, you go help. Whoa.
We got a bunch of nice Spanish girls out there. And sometimes they grab me by the shirt. You come work me on my machine. You hurry up. We miss the people we used to work with more than place, you know. Sometimes I still see some of them girls at Walmart. It's like a kind of like family reunion when you see them. I got them girls hooked on peppermint candy in the plant. I used to go buy a Cracker Barrel with some kind of stick peppermint. And I'd get them out, get 2 or 3 bags, so I take that thing through and walk in and pass them around. And they got rocking this time. If I ever went a day and didn't bring them no candy, one of them, her name was Sylvia, she said, she looked at me, she pointed her finger, she said, you come here. I said, what is it? She said, you know, bringing me no candy today? No candy today? I said, I'm out. She said, when are you going to give us some more candy? I said, I'm going to go to Cracker Barrel. That's what they're doing. So I had to go back to Cracker Barrel and get some more candy. So you might want to go. What do you think? All right. So at this point, you got rid of your salt fill. And then what I would do next for a basic straight edge alignment is plug your straight edge up here. We know we got the couplings orders. Let's loosen this up. Let's loosen this so that we're not bound there. So we're not influenced by that.
Try 76 minutes.
Say the 16th. Yeah. Just loosen them so that they're going to crack together, but they're not bound together.
You're not my balls.
So this room is matter of fact, there's gas in there. So the gap needs to be brought in some, but then you maybe get about 3,000 in there. That has to be very smart for people getting this in. And then, actually, you can actually bring them together by boosting this to bring them together as a last step. It can be done that way. There's more than one way of doing it. Go ahead and throw a straight edge up there. Where's that piece that we're using? Little carbide piece. Put it up here. We put this up here, and we look to see if we have any daylight, and we got a little bit on this side. See that? On the other side. So let's find out how much that is. It ain't much. You would check that with a feeler gauge. You use this. So across the top. This is a little bit lower than that. And if you push right here, that's where you'll see the gap at, like that. Because it is a little bit lower over there. You see that? Very little, almost none. How much was that? You actually got more this way than you do up here. These jack bolt tips can be used to bring it that way. Brandon, how you doing there?
I'm doing all right.
Yeah, make sure you go back and watch those other videos so you can get credit for being here.
Okay.
Get your worksheets done. Try to get them done before the end of the week, because again, I can't grade them next week. They'll be cutting on me next week. So.
Okay.
Okay. So that, just for right now, let's say that's good enough on that one. Now shoot it on this side here. Now put it in there and see. It actually seems like more to me. It feels like more time. That feels more like, I don't know, maybe 20 to me. It's kind of just off of the skin there, feel like it might be about 20. Plus or minus 10 pounds.
Cheap number.
I'll give you a little slack there.
You were 10 to 30.
What was that right there?
Put it back
It's
up there.
going to be way more than
Put it
5.
back up there. See how good they're wood.
That's about 20. It's going to be somewhere in the range of 20, I believe. 40, 20. You feel a drag? Yeah. What I say? Yeah.
Come with experience.
I tell you, out there, man. Seriously, kind of what I worked 20-something years, man. Actually, 22. Shimming machines. If we had rolls of shim stock on these rolls. If we had to cut them with our 10 snips. And here was the preset thicknesses that we had. We had 5,000, 10,000, 15, 20, 25, 30. We had them in certain increments. And you got to a point where you could feel it, and just by feeling you knew what thickness it was. Because you had them all in there time. Not because you got a computer brain, and not because you got calibrated. Well, your fingers, I guess they do kind of get calibrated after a while when you look at something.
Same way with sheet metal in the house, well, I can look at this.
Yeah, exactly. Hey, yeah, well, that says 5. If it says 5, and I feel that, and I get used to that, then I could go blindfolded and feel something. I could tell you which one is 5. Not because I can measure that, but because of the feel, the bend, how well it bends. So we got to listen. So what we have to do here, look, the video, that's fine. When this bumps, it moves and it has to be turned back on. The camera does. Okay. It actually loses connection a little bit sometimes when it gets bumped around. Just the USB connection is complete. So basically, look here. The motor was sticking out 20 thousandths further than the driven. So we got to take these jack bolts right here.
We're using this. Not using this camera. It's using your camera on it.
Okay. All right. Okay. We got 12 o'clock. We're going to be in here. Everybody with worksheets and lamp whatever. Okay. Let's go. Yeah, I shouldn't hit integrated. Well, don't have mercy. Where's the what happened there? Is it still plugged? It's still plugged in. It's still there. Hold on. We got to get the webcam back. Camera. Oh, go into here.
There's no pull down. It's not recognized.
So we got to unplug it, plug it back in. So yeah, I'll do it right there.
That's interesting.
There's that. Strange.
You know where the days in you?
There you go.
There it went. Yeah, it was right. Here's what it was. Yeah. Yeah. Okay, so Brandon, we're getting ready to close this thing out. It's kind of in closing here. What we found is that right here, that the motor was sticking out this way. And let's just say sticking out that this is north, east, and south that way, because I ain't looking north here. The motor coupling was east 20 thousandths, east too far, compared to the driven, if this is the pump shaft, for instance. So we got to take the motor and go 20 thousandths that way, and we're going to use these jack bolts at the figure here. So if you want to see these,
Yeah, I got it.
the jack bolts, you can do it and bring them evenly that way and move the whole thing. When you look, let's get a bird's eye view here. If you look here, you got jack bolts on this side. On this end, you loosen these jack bolts here. And you loosen them the same amount. And then come on this side, and you turn these the same amount by counting the flats on the bolts. Let's use the bolt here real close. If you want to move both sides the same amount, you count the flats on there. And if you go say, the 2 flats or 3 flats, you would go 2 or 3 flats on this side, and it would take the whole base plate evenly instead of skewing it. So that's what we'll do on Thursday, is we will do that to finish this up. Because these guys that took off on, and it's actually overclassed. We've run over it, and I don't want to keep Patrick tied up. So we're going to pick it up right from this point Thursday. We'll finish this alignment, and then we'll move on to dial indicator. We'll actually throw the dial on there to do a verification that what you've done is actually it's suitable. And see, this is gonna strap on like this. Straps on something like that. We're going to start out like this. We'll zero this out and then run it around once the alignment's done. The alignment's not done right now. If you start out at 12 o'clock and you have it on zero like that, and then you bring it around and then bring the camera to the other side and just see whatever amount of however much it's off. So how much do you see this off there?
Two.
Just by 2. Now that's pretty darn good. That we knew that the vertical was okay, right? The vertical was all right. Now let's shoot it this way and see what we got. Now, actually pretty darn good there. Let's go back up this way. Actually, I don't have the plunger engaged. See that? The plunger's not engaged with the gap in there. So we've got to bring it down. I have to do the plunger. It has to be engaged about somewhere mid-stroke in there. You got to bring it in like that. And I've got to lock it in. I've got to lock it in here with the thumb wheel behind it. So the issue was it wasn't even engaged. So you got to go halfway in the stroke roughly like that, and then snug it up. Snug the thumb wheel like that. So there's some engagement in there. So then you start out with zero. I didn't even have it set up in mid-stroke on the plunger. Okay, so we'll start out at 0, and then we bring it on around. Now see, it's showing. If we start out in the travel there, you see it start out at 0. Actually, go here, it's 0 like that. And then as we go around real easy, you see it growing like that. So you can see the change in it there, about 15 thousandths there. And then you see it down in there. It's actually better. It's only like 2 thousandths there. You know, we knew that vertically it was good. We knew that it was very close vertically. It's within like 2 thousandths vertically. But horizontal was where it was off. And you can see that. See that amount there? So it looks like it needs to move about 15 thousandths roughly. And that's what we said it was going to do, right? Mm-hmm. We were going to do that with the base plate. So this is agreeing with what we said, that horizontally, east-west wise, that's the motor's got to move, correct that. So the dial indicator can be used to confirm, you know, what we've been seeing, and we're back at 0 there. See? So this is just another way to see it. You know, at the 9 o'clock position, this is where you have the most error. Back down at 6, you're actually within tolerance there. And we knew that. You know, we knew that we knew when we threw it across here like this that we were extremely close. So that was your up, down, your north south reading, which was actually good. You know, you were within 2,000 there on the dial. So we'll pick up from this point Thursday. We'll finish this thing up, get it dialed in good, and then turn it on, and all that good stuff, and then we can go with laser. We have a laser hookup, and the laser, if you want to bring it up this way. That's a set right there that we'll get into as well. They clamp on. And it's a pretty sophisticated thing that we're going to go through that together. Anyway. Okay, so we're going to end this session out, and again, thanks for watching, and Brandon, let me know if you have any questions on anything, and we're going to wrap all of our worksheets and stuff up this week. I'm going to try to get all that stuff finalized by the end of the week before my surgery next week, because I won't be doing any of that thing. So next week will be study week for y'all. Print your worksheets from Google, even if it's just a PDF that you can save on your device, and then study the 17th and the 19th next week. Come in person on the 24th, Tuesday morning at 9 day in, here's some shop in that classroom, and someone's going to take y'all to a computer lab where you'll do your exams in Moodle right here on campus. And if for some reason, Brandon, if you see that you couldn't come, you need to let me know super quick, because we have to make some arrangements. And listen, let me give you a phone number, because if you find out you can't come and I'm actually in the hospital, I'm going to give you a number to call Barney Grady, okay? Are you still with me, Brandon? I'm gonna text you his number, because I don't hear you in my session right now. I'm gonna go ahead and end it, but I'm gonna text you Barney's number, and you call him if you end up thinking that at the last minute you can't come on campus, and you got to discuss it with him as far as your range. But anyway, thank you for watching, whoever's gonna watch it. Thank you for cameraman Patrick there. Hey, look, if for some reason at the last minute, if you find out you can't come to campus to do that exam, like if you for quarantine or whatever, you need to call Barney Grady. I'm going to send you his number now.
Okay.
Because I won't be able to help you at that point. I'll be off campus, but Barney would be able to tell you what to do at that point. But if at all possible, try to be here for it. If you're clear, if you tested clear, you know. But if not, you call Barney, okay? And I'm sure he'll have an idea of what to do. And I'm going to talk to him in advance about that, about what if, you know.
Yeah.
Okay. All righty. You got any questions, Brandon?
No, sir.
Okay. I'm going to go ahead and end the video, and I'm going to post it after a while when it uploads. And so thanks for joining. And if you need help getting called up, let me know. But give it your best shot so that you can get full credit past this class, okay?
Okay.
And I hope, and we're praying for you and your daddy, man, that everything will clear up in your mother too, okay?
All right. Thank you.
Thank you, buddy. God bless you, man, and we'll talk to you later.
All right. Later.
Okay.